Hey guys, Jake here coming at you with another live math lesson this week. Happy Labor Day weekend. Took a little bit of a long weekend, so we're doing this live stream on Tuesday this week instead of our normal Monday time. But still doing it either way. Today we're going to be talking about limits. I know it's the start of a new term for a lot of people right around now, and limits is one of the first things that are frequently talked about in a calculus class. So wanted to take a little bit of time going over some stuff about limits. So today we're going to be talking specifically about kind of the relationship between one-sided limits and two-sided limits. Basically how you can, use one-sided limits to find two-sided limits, and just kind of in general how those two things are related, what they tell you about each other, all that kind of stuff. So going to be going over a couple of different topics here that should really help you kind of understand the difference between one and two-sided limits and how to use them with each other, because they are obviously very closely related and pretty important when you're talking about calculus, basically. So we're going to have a couple different examples here to kind of nail down, a couple of main points I want to make about limits. But let's go ahead and jump into the first problem here. So we're going to start off by just doing this problem. So explain what it means. Explain what it means to say that the limit as x goes to 1 from the left of f of x equals 3, and the limit as x goes to 1 from the right of f of x equals 7. So I want to just kind of take a quick moment to just kind of talk about notation, first of all, because I know I just read these out loud to kind of give you a hint of what these two things actually mean, or how you would read them, I should say. But I want to take just a quick minute to kind of talk about these two things. So in general, you're probably familiar with the kind of limit as x goes to some number, let's just say 1 in this case, of some function. And if we say that equals something, let's just say 10, for example. I'm not saying that that's what this tells us, not at all. I'm just kind of coming up with a random example. This basically is telling us the limit as x is approaching 1. So as x is getting closer and closer to 1. Notice there's not a plus or a minus here, right? So this is kind of the notational difference between one-sided and two-sided limits. If you don't have a plus or a minus as like a superscript, like a really tiny writing up above your number that x is approaching, like here we have a minus sign, here we have a plus sign. If you don't have anything there, like in this case down here, that tells you you're looking for a two-sided limit. If you do have something here, like a minus or a plus, that tells you you're looking for a one-sided limit. So notice this, if we were to say the limit as x goes to -1, that is not the same as saying the limit as x goes to 1 with a negative sign up here. These two things are different. The negative sign up here does not mean we're looking at x as it goes to -1. What this means is, a kind of better way to think about it is the limit as x goes to 1 from the negative x direction, from the negative side. In other words, from the left. So if you have a minus sign up here, that tells you that you're looking at the left-sided limit. If you have a plus sign up here, that tells you you're looking at the right-sided limit. Okay, so that just indicates that you're looking for a one-sided limit. So that is really all that is kind of given in terms of what the limit as x goes to 1, or, from the left or from the right. The fact that it tells you that it equals 3 and it equals 7, that basically just tells you that our left-sided limit as we approach x equals 1 of f of x is 3, and our right-sided limit as x approaches 1 from the right side of f of x is 7. So that's really all those two notations or statements are really telling you, is the left-sided limit of our function as x approaches 1 is 3. The right-sided limit of our function f of x as x approaches 1 from the right is 7. Okay, so that's really what is kind of stated here within these two limits right here. So the next kind of question that this problem asks us, and the next kind of logical question to think is, in this situation, is it possible that the limit as x approaches 1 of f of x exists? So like I just kind of talked about, we don't have a plus or a minus here. So what that tells us is, what this is asking us to find is the two-sided limit as x approaches 1 of our function f of x. So what do we know about the two-sided limit based on the two one-sided limits that we're given? We have a left-sided limit. We have a right-sided limit. What do those tell us about the two-sided limit? That's basically what it's asking us to think about here. Before we get into that, I do just want to throw out there, if you are getting some value out of this video, do me a favor and hit that like button down below. It's a huge help to my channel. We can keep, getting these videos out to more people, keep growing the Jake's Math Lessons community, and keep crushing it together all term long. So hit that like button if you're getting some value out of this so far, and we'll carry on here. As always with these live streams, if you're joining us live, if you have any questions along the way, whether they're on topic or not, just throw them in the live chat, and I'll do my best to answer any questions you have right in the moment. That way you don't have to worry about taking questions away from this live stream. Instead, get questions answered. But let's go ahead and discuss this. So if you have information about both one-sided limits like we have here, what do those tell you about your two-sided limit? Well, it's really pretty simple. Two-sided limits, in general, this is a general rule of thumb when it comes to two-sided limits. A two-sided limit of a function as x approaches some value, so the limit as x approaches a of f of x, is going to exist, so it exists, if and only if you ever see this little if with two f's, IFF, that means if and only if, which means basically it'll exist if this happens, and if these happen, that also means it exists. Basically, it implies in both directions. So our two-sided limit exists if and only if both one-sided limits exist. So we need the limit as x approaches a from the left of f of x to exist, and we need the limit as x approaches a from the right, so from the positive direction, to exist. So both of these one-sided limits have to exist, and not only do they both have to exist, they have to equal each other. So we need both one-sided limits to be equal in order for the two-sided limit to exist. And if that's the case, then all three of these limits are going to equal each other. The two-sided limit is just going to be equal to whatever both of the one-sided limits are equal to. Okay? If one of these one-sided limits does not exist, or if they don't equal each other, then that means our two-sided limit does not exist. So the limit as x approaches a of f of x does not exist if either of these two don't exist, or if they're not equal. So basically there's kind of three situations there that can cause that. If the limit as x approaches a from the left of f of x does not exist, the limit as x approaches a from the right of f of x does not exist, or if the limit as x approaches a from the left of f of x does not equal the limit as x approaches a from the right of f of x. So even if they both exist, but they're not equal to each other, that tells us that our two-sided limit does not exist. Okay. I do also want to throw out there, these are topics that are covered on my free Calculus 1 study guide and my complete Calculus 1 package. If you want to check those out, there are links to both of those things down in the description. My study guide, like I said, is free. You can go get that for instant download. It's available. You can have it in a minute or two if you just follow that link and go right over there. But yeah, that pretty much is everything that one-sided limits and two-sided limits tell us about each other. So, kind of bringing it back to this question here, in this situation, is it possible that our two-sided limit as x goes to 1 of f of x exists? Well, you can see we have our left-sided limit. We know it exists. We have our right-sided limit. We know it exists because it's equal to 3 and 7 respectively, but 3 does not equal 7, right? So since the two one-sided limits do not equal each other, we're in this situation right here. We have the two one-sided limits not equaling each other, which tells us that our two-sided limit as x approaches 1 does not exist. So that's really basically telling us it's impossible that this exists. So that's really it for that first question. I'm not seeing any questions in the live chat. As always, if you do have questions along the way, just throw them in the live chat. I'll do my best to answer any questions you have. But let's go ahead and move on to this next problem here. So we have, for the function f, whose graph is given, state the value of each quantity if it exists. If it does not exist, explain why. So let's just kind of go through these one by one, talking about what these different notations mean and seeing, on our graph, what does that tell us? So let's go ahead and start with A here. The limit as x approaches 0 of f of x. So this is, like I kind of talked about in the previous section, we don't have a plus or minus sign right here. So notice this and this have little plus or minus signs above and to the right of the number that our x is approaching in our limit. Since we don't have that, that tells us we're looking for a two-sided limit in part A here. So a two-sided limit, basically what that looks like graphically, how you kind of figure that out on a graph, it's basically saying, let's imagine that we are like, I like to think of it like you're a little bug, you're a little ant walking along this function, okay? So we want to look at when x approaches 0. So first of all, first thing you want to do, look at your x-axis, find the number that x is approaching. In this case, x is approaching 0. So let me grab a darker color here. X is approaching 0. So that's right here on our x-axis. Basically what we want to do is draw a vertical line from there. Basically imagine looking at all x equals 0 values. That gives us this right here. And we want to imagine being an ant walking along this function from both sides towards that x value that we're looking at. So towards x equals 0. We're going to come from the right side. Since we're looking at a two-sided limit, we're going to come from the right side and from the left side. So if we're on this function, moving towards x equals 0 from the right and towards x equals 0 from the left, what a limit is asking is what y value do we get closer and closer to? What y value do we close in on as our x gets closer and closer to this x equals 0 value? So in this case, you can see as our x gets closer and closer and closer to x equals 0, basically closer and closer to this point right here, what y value, if you imagine being that little ant walking along the function, what y value do we get closer and closer to? Well, you can see from both sides, we're basically going in on this same point right here. From both sides, we're closing in on this spot right here, which would be at x equals 0 and y equals 3. So you can see basically by kind of walking into that point right there, following along our function, we close in on y equals 3, no matter which direction we go from. So since both one-sided limits go to the same point, that two-sided limit would be that same y value as well. Okay. So let's think about, actually, let me try something here. I'm not sure if this will, yeah, it will. Okay. So this was 3. So now let's go on to part B. So part B, C, and D are all looking as x approaches 3. But notice the difference between these three parts here is as x approaches 3 with a little negative sign, a little plus sign, and then no sign. So that's saying basically as x approaches 3 from the negative x direction, as x approaches 3 from the positive x direction, which means as x approaches 3 from the left, and then as x approaches 3 from the right. And then the one with no sign means the two-sided limit. So just like we kind of talked about before, if both one-sided limits exist and are equal to each other, then the two-sided limit will also be that same value. So basically, if part B and C give us the same number, part D will also give us that number. Otherwise, part D will be does not exist. So let's again think about this kind of ant analogy. Imagine we are an ant walking along this function. Now, in this case, unlike the prior example, we have a one-sided limit. We only want to look at as x approaches 3 from the negative x direction, from the left. So if we're coming from the left, so first of all, where is x equals 3? Well, it's right here. Okay, x equals 3 is basically a vertical line right here. So as x approaches 3 from the left, so as we basically, walk along our function, starting from some x value that is to the left of 3, as we get closer and closer and closer to x equals 3, what y value do we get closer and closer to? Okay, so keep in mind, I keep using the phrase closer and closer to. Limits don't care what value the function actually is at that point. We don't care about the fact that this function has a hole right here. That doesn't matter, because the hole only affects the function at x equals 3. But limits don't care about that. Limits only care what happens as x gets really, 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 really close to that point. Well, as x gets really, 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 really close to that point, we're still on this line, getting closer to it. As long as we don't get to x equals 3, we will never get to this hole. We'll still be on this little chunk of our function right here. And as we're moving in this direction, getting closer and closer to x equals 3, what y value are we getting closer and closer to? We're basically getting closer and closer to where this hole is drawn, but that gets us closer and closer to this y value right here. Y equals 4. So this one-sided limit is going to be 4. Okay. Now, similarly, if we approach x equals 3 from the right side now, like in part C, we're on our function somewhere over here, some x value greater than 3, and walking along our function to the left towards x equals 3. As we get closer and closer to x equals 3, what y value are we getting closer and closer to? So now approaching from the right, you can see that we're basically walking closer and closer to this hole down here, or where this hole's drawn, which again just gets us closer and closer to the edge of this chunk of our function. So as our x value gets closer and closer to x equals 3, we're just getting closer and closer to this spot right here, which is at y equals 2. So this is going to be 2. Okay. So now, like I already kind of said, in order for the two-sided limit to exist, both one-sided limits need to exist, and they need to be equal to each other. In this case, we have our left-sided limit is 4, our right-sided limit is 2. Although both of them exist, they're clearly not equal to each other, right? 4 does not equal 2. Therefore, this two-sided limit does not exist. We can't find the limit as x goes to 3 of f of x. Okay, and then finally, we have f of 3. Okay, so this is different. This is obviously not a limit, right? It's not saying the limit as x goes to 3 of f of x. It's saying what is f of 3? Well, f of 3, this is opposite of what a limit is asking, because like I kind of said a minute ago, what a limit is asking is what happens as we get really, 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 really close to these x values here. We don't care what happens at those x values, but what happens as you get really close. That's not what this is saying. This is saying the opposite. We don't care what's happening around x equals 3. We care what's happening at x equals 3, that one point. We're not moving along our function in this case. We're just looking at that one point on our function. What is it? Well, if you look at x equals 3 and then just go vertical basically until you actually hit your function, where will you hit it? Well, we won't hit it here because at y equals 2 we have a hole, right? So we actually keep passing by our function there. We hit it right here. And if we keep going up, we won't hit it anywhere else, right? We have another hole up here, so it doesn't count there. And if we keep going up to infinity, we don't hit our function again. But we do hit our function right here because we have this point, which I'm kind of covering up and making hard to see, but you can see we have the point right here. Nowhere else along this vertical line of x equals 3 do we have our function drawn. We just have these other two holes, which technically we have to draw a hole so that we can show that a hole's there. But obviously, if you're thinking about what your function actually outputs at that point, it would be where the actual point is, which is y equals 3. So f of 3 is 3. So you can see Our one-sided limits are 4 and 2. Our two-sided limit does not exist. And then the actual value of our function is 3. So that really just kind of reiterates the point I was making earlier about limits not caring about what's actually happening at that point, right? Because if these one-sided limits did care what was happening to our function at the point x equals 3, our function is 3 at x equals 3. The output of our function is 3. But that's not what either of these one-sided limits were, right? They only care what's happening around x equals 3 for x values really, really close to x equals 3, not at x equals 3. Okay, so I hope that kind of helps clear up, one-sided limits, two-sided limits, how they're all related to each other. If you do want to keep learning about limits, I have made other videos about that. I'll come back, and if you're watching this live, just go check out my channel for limit videos. If you're watching this later on, I'll come back and put some other videos for you to go watch somewhere over there. So you can go click on those. Keep kind of nailing this down, because this is, a great start, but there's a lot more to learn about limits. So I have made a lot of other good videos on that. I'll go ahead and put one of them up there so you can go check that out. If you get some value out of this, do me a favor, hit that like button, hit that subscribe button so we can keep crushing it all term long in calculus. And I'll see you next Monday night.